Some of the most intriguing and top-secret weapon development projects in the aviation industry are those for sixth-generation fighter jets. They mainly fall into two categories, those that have received a lot of attention and those for which we don't know a lot. The Next Generation Air Dominance (NGAD) program of the United States falls in the middle. Its schedule and cost are frequently discussed, and the U.S. Air Force even said that a prototype of the jet had been flown. The U.S. has, however, provided very little information regarding the qualities or even the appearance of the aircraft, in contrast to the Tempest, the FCAS, or the FX. First, there are two initiatives known as NGAD, one of which is supervised by the U.S. Navy and the other by the U.S. Air Force. Both see the fighter jet of the future as a system of systems, or a group of various aircraft working together to accomplish various missions. While a human fighter jet still occupies the center of this configuration, a swarm of drones of diverse sizes and shapes that are under the direction of the jet account for a large portion of the offensive power. Additionally, several businesses are already developing these programs. Instead of using its standard procurement procedure, the Pentagon hired businesses to complete specialized tasks, like creating particular components or subsystems. While recent reports indicate that the U.S. Air Force's NGAD program has at least partially abandoned this new technique, the procurement procedure for the service's sixth-generation fighter remains distinct from the methods used to pick fifth- and fourth-generation planes. Northrop Grumman is credited with creating the earliest concept art for a sixth-generation fighter jet, which predates the NGAD program fully. They depict a tailless twin-engine aircraft outfitted with a direct energy weapon and can be dated to at least 2009. Even if the photographs might be related to research projects that were underway at the time, there is simply insufficient information to determine whether the corporation had a sizable investment in sixth-generation jets at the time. However, those early pictures resemble the representation that the business unveiled in 2015, just a year after the NGAD program was started, to some extent. A tailless blended wing-body aircraft was shown shooting a laser at approaching missiles in the picture. The overall design was somewhat similar, and the direct energy weapon idea was carried over from the 2009 image. However, this new representation wasn't just a placeholder for a laser weapon, it was a genuine piece of concept art. In 2024, the U.S. Air Force intends to hold a competition for drone wingmen to support its sixth-generation fighter aircraft. As a part of the Next Generation Air Dominance (NGAD) strategy, which includes the development of sixth-generation aircraft, the program aims to field one or more categories of unmanned aerial vehicles. Fighter jets like the F-35 and the F-16 have expanded in-flight capabilities thanks in large part to autonomous wingmen. They are placed behind or outside the leading aircraft in a formation to conduct electronic warfare and reconnaissance missions, as well as to act as a decoy to draw enemy fire. The use of autonomous systems as fighter wingmen might result in fewer military fatalities and greater defense and support for a combat jet. They have the ability to launch their own missiles to destroy enemy assets, jam hostile signals and electronics, and independently scout and map targets. What exactly is a sixth-generation fighter? Only 3 countries, the United States, Russia, and China, have designed and constructed models of fifth-generation aircraft because they are so expensive and technologically sophisticated. Stealth, supercruise, supermaneuverability, and interconnection are still state-of-the-art technological advancements. Even nevertheless, the great nations are already planning for the future, vying with one another, and thinking about the sixth generation of fighter technology. Only in theory do sixth-generation fighters exist. The US, Russia, China, Japan, the UK, and France are among the nations developing sixth-generation aircraft, some of which have never even produced a fifth-generation fighter. The sixth generation of fighters has not yet been released, and it is generally believed that it won't until the 2030s. Even though the sixth generation of aircraft is still in its infancy, a number of distinctive characteristics have come together to define what a sixth-generation fighter is. In particular, all of the fifth-generation deserving skills for air superiority, ground attack, and other contemporary skills will need to be enhanced. The aircraft industry is less concerned with the close-quarters dogfighting that characterized aerial combat in the 20th century. Instead, ground assaults, cyber conflict, and even space conflict are becoming more important. The use of missiles with a range beyond visual range is still crucial. The capability to operate in a manned or unmanned configuration will probably be incorporated into the next generation of jet fighters. Sixth-generation airfighters will also need to integrate with a wide range of other jets, drones, personnel, and sensors in a saturated network aimed to provide warfighters a thorough image of the battlespace, much like the F-35 and the fifth generation of airfighters. Several design components will be used to accomplish the performance attributes anticipated of a sixth-generation fighter. The brains of the aircraft, advanced digital platforms with networking capabilities, onboard AI, data fusion, and advanced communications technology, will serve as the cornerstone of sixth-generation technology. The jets will have components that make it easier for the pilot to work in unison with the machine. Therefore, new fighters will probably include virtual cockpits displayed into the pilot's helmet, giving the pilot 360 degrees of visibility, in addition to a modern instrument panel. Like their predecessors, sixth-generation fighters will need to have cutting-edge stealth technology, especially as air defense systems become more effective. Variable cycle engines, which can function effectively in a number of situations, including cruising without using a lot of gas and being able to offer high-end thrust and performance, should be included in the new jets. According to some, sixth-generation aircraft may even be equipped with directed energy weaponry, such as laser CIWS. It remains to be seen if the country's emerging sixth-generation technology can implement such a variety of unique technologies. Financial limitations will undoubtedly be a significant influence. There are numerous sixth-generation fighter concepts in development. Working on the FX program is Japan. The FX will be the nation of Japan's first stealth program ever. The first sixth-generation fighter on the European continent has been assembled by various nations. On the Future Combat Air System, the United Kingdom, Sweden, Italy, France, Germany, and Spain are all cooperating. Uncertainty surrounds the ability of the 6 countries, who stand for the continent's leading powers, to successfully coordinate such a massive undertaking. The PAC-DP, a planned interceptor aircraft that could replace the MiG-31, is one of many projects being worked on by Russia, a country with a long history of great aerospace accomplishments. India is still working on a fifth-generation model as it attempts to match China's remarkable military build-up, but it is also looking ahead and beginning to make plans for the development of sixth-generation technology. And China, who has already developed a successful fifth-generation jet, the Chengdu J-20, has started looking into a sixth-generation fighter aircraft to support their ever-growing military. Since the U.S. is still at the forefront of aerospace technology, they should be the ones to produce the first sixth-generation fighter. Sixth-generation programs are currently being developed by Northrop Grumman, Lockheed Martin, and Boeing. The F-22 and F-35 were examples of U.S. efforts to build fifth-generation technology, both of which were notoriously hampered by delays and cost overruns. Although those programs received a lot of criticism, it's possible that they were simply attempts to push the limits of aerospace technology. Similar difficulties may exist when pursuing sixth-generation technology.